Hello, everyone. Are we here? Okay, please try again. Okay, please, if you're in this, okay, good evening. If you're in this class now, you can just signify your presence by saying hello. You know. Good evening, good evening, everyone. Okay, I'm just putting a few finishing touches into the link sharing and everything so that we can actually start. Mm, Second part. Okay, good evening. I believe everybody is here now. Although so far, I think I have 11 people currently in class. And we're continuing our class from yesterday. Okay, so for those who are just joining this series for the very first time, this is Data Analytics Africa. We have a community, we have a group on Telegram. This started out as a small initiative through Twitter where I discussed sharing knowledge on data analytics and bringing people who were interested in building a career in data analytics into the fold. Um, so far, we've taken a few classes. We've taken two classes so far, and you can always find the link to those classes. Excuse me. You can always find the link to those classes either through this YouTube channel or on the Data Analytics Africa channel. The Data Analytics Africa channel is on Telegram. It's DA Africa. At DA Africa, where you can actually view materials that we share from time to time. And you can join the Telegram group. I'll be adding the Telegram group link at the end of this session. In the meantime, I could also add it to the chat box, and you can always pick it up from there. That's for you who are probably joining this from a different source other than the Telegram group where we have our regular discussions. So if you're interested in joining the group, that's the link for the chat. I mean, for the group, you can join that link and find yourself in our group. Okay. So once again, my name is Adetayo Kolade, and I'll be the one taking you through some of the classes. We are going to have quite a number of classes, more than one, two, three, four, five, six, seven, eight, right? And there would also be other facilitators in this training. But for now, me, myself, and I will be starting most of the classes. Okay. In the beginning, the very beginning, and I'm doing this for people who are probably just joining in on this, who probably were not here before. One of the reasons why I started this group or this series was to educate people who are interested in the career in data analytics differently from the way most popular data analyst trainings go. You have a lot of trainings where people just dive right into the tools themselves. I know everybody is eager to learn how to use one or two tools like that. So now this is not just about data analytics, right? It's about data analytics. It's about data science. All right. It's about making the cross from or making the leap from um, excuse me, it's about making the leap from being a data analyst to also getting the crux of being a data scientist. Okay, we at the end of the day, in as much as I know that not everybody is going to be a data scientist, I believe it is important that all of us who are interested in a career in data analytics should know what the career path is like and what the bigger picture for being a data analytics professional is. It doesn't stop at just carrying out basic analysis with sample data on Excel. It doesn't stop at just playing around with small snippets of data. It involves looking at the bigger picture, which is using data analytics to solve problems, to solve real problems. I mean, most people tell you, oh, you want to learn a career, you want to start a career in data analytics. Okay, learn SQL, learn Power BI, and you're good to go. I don't think it stops at that. I think it's a process. The data analytics or business analytics is actually a process, and it involves starting from the basic rudiments, understanding the processes involved in data analytics, and making the best out of it. Anyways, to not drag this for too long and to kick us into the mood as quickly as possible. Yesterday we started by talking about what data analytics was, the processes involved in data analytics. I want to bring up the just a minute, please, people. I want to bring up the slides from yesterday, which you don't need to bother yourself about. I'll just use that for a review. All right. Um, so we talked about an introduction to data analytics yesterday. How I'm just doing a recap for those who were not in yesterday's class but who are in today's class. I try as much as possible to ensure that we do not spend more than 1 hour in each class, considering it's in the night and people want to go to bed. And particularly for tomorrow, where people would actually be going to work, so we will try and round this up as quickly as possible. But basically, yesterday we just did an introduction and we talked about the technologies for analytics, the applications of business and data analytics, a brief definition of what analytics was, so business analytics and data analytics. We talked about how the business analytics process goes from gathering data through applying tools and techniques on that data and then using that combination to generate business insights. Okay, we talked about how all the processes involved in the business analytics stage, all the stages involved in the business analytics process. I am sorry, I was supposed to have shared the slides from yesterday with you so that you could review that and be more have a better understanding of what we're doing today. But I'm so sorry about that. What I'm going to do is that at the end of this class, unfailingly, I'm going to share with you both slides from yesterday and today. Okay, um, that's that for that. But basically, following up on the recap, we talked about the various applications of business analytics in personalized marketing, medical analytics, mobile advertising, and so on. We talked about also in financial services how it's being used for credit fraud detection and then credit score ratings and so on. We talked about a particular use case of data analytics and its advantages in manufacturing industry, and we spoke about the data analytics process and how involves from identifying your data sources and so on. And we talked about the stages of big data business analytics. That was one very, very important thing we spoke about. We talked about the descriptive analytics, diagnostic or discovery analytics. We talked about predictive analytics and also prescriptive analytics. Now, before I go on, let me also mention that this is a very, very interactive class where I expect you to be able to ask questions without necessarily waiting for me to prompt you. um, because of the speed which we try to run through, please, it is very important that If there's anything that I'm saying that you're not particularly satisfied with, you can just quickly ask me questions. All right, drop your questions in the chat box, and I will take those questions as they come. All right. Yesterday I also showed us the scheme of work, although I dropped that scheme of work partially on the Telegram group. But so that's that for that. Anyways, so much for introduction and everything. Let's dive straight into today's business. Now, introduction to data analytics part two. I am very sure that we will not conclude this introduction to data analytics tonight because this is like a continuation of all the hula value we were talking about yesterday, and it's actually a bit lengthy class. Initially, what I thought was that I was going to be able to do in the introduction to data analytics, conclude it, and then start off with our introduction to Excel, since Excel is like the primary and most common data analytics tool that everybody uses. But let's just dive right into this. So starting from where we stopped yesterday, we talked about the life cycle of a data analytics project yesterday, and how it involves several iterative stages of back and forth, where you come through to the your discovery. From your discovery, you go to data preparation, and if you're not satisfied with your data preparation, you go back to discovery. It's always like it's a series of back and forth. Okay, you try to discover your data first of all, which involves getting your data. We're going to go deeply into all of these phases one after the other. Going forward, I think for tonight I stopped us at model planning or model building. Um, Now, most of the popular things most people do, or what a lot of people are very, very familiar with, and which are the tools people get to really use, is the last point, which is the result communication. I mean, we're really used to doing basic, what we call data analysis, but which is just wrangling a little bit of data with by applying some statistical models on it. Sorry, statistical methods on it, and then throwing it out there with a chart or a graph, and then we buzz it all out and say, okay, yes, I've done some data analytics. Yes, I can use Excel very well. I'm a data analysis guru. I mean, it doesn't stop at that. There's quite a lot of lengthy processes. And because this is like I will say that this is a um, partial correlation. There's a partial correlation between, in fact, let me just put it this way: the entire data science life cycle, the entire data science process or project life cycle is also similar to what you call the data analytics life cycle. So let's just proceed. Please, if you have any questions, you can always ask me in the chat box. I will be too glad to answer your questions. Now, the first phase of your data analytics project is your discovery. Okay, this is the point where you make a few things like what this is the point where you get to do your questioning. You get to question the problem you're trying to solve. Okay, it is at this point you define the problem. All right, and at this point where you have a very basic understanding of what you are trying to achieve. Every data analytics project or every data science project is like a series of processes, and the very first thing is, in most data analytics, I mean projects, you're trying to solve a problem. Okay, I know I told us something yesterday that we should come up with five cases, five use cases of data analytics, five cases where you would need data analytics to solve certain things. And I don't know how many of us actually went through and did that assignment. For those of you who did it, clap for yourselves. If you want, you can actually drop your answers in the chat box. If you don't want, you can skip that. Well, nobody will beat you for it. Lol. Now, if I say lol, don't mind me. I'm one of those people who say lol. Like, I mean, come on, it's laugh out loud. But anyways, I would say lol and move along with it. Well, like I was saying, so basically, every data analytics project or every data science project is a problem solution process. Okay, and the first thing you have to do for every problem solution is to define the problem. Okay, if you are in the pharmaceutical industry, for example, hi Michael Aliyu, welcome. Just in your message now. Don't know if you've sent that quite a while ago, but Hello. If you have any questions, you can go ahead. Now, imagine you being in the pharmaceutical industry, for example, and your organization is trying to come up with using data that was gathered over medical trials to come up with a solution for probably um, getting the cure for cancer, or example. Now, the problem there, or your problem statement or problem definition is, we're trying to get what a cure for cancer, right? And that problem statement involves gathering initial hypotheses from stakeholders and domain experts to have better perspective about what the problem is. Okay, so in this phase, you are basically asking questions. All right, you're asking questions. And then you're looking forward to people who have either people or sources of proper data or proper information on what that problem is, and they're using all of that to build your so it's called an hypothesis, right? For those of us who are science students and actually did took science courses and everything, I know that you have a very good idea of what building a hypothesis is, right? So it's more or less like a postulation as to, okay, this is our problem, and how best are we going to go about it. Now, analyzing the literature associated with the problem and answering the following questions. First of all, what is the problem that we're trying to solve? You know, in the pharmaceutical case, we're saying we're trying to solve, get a cure for cancer, right? So we're stating the problem as generating a cure for cancer. What is it not? Problems that are not caused. Now, let me see how I can bring this. Um, so we say, what is this problem not? Okay, so it's basically looking for a cure for cancer. It's not looking for a cure for AIDS, all right? And whatever hypothesis we're building, we're focusing on creating a cure for cancer. Even if whatever questions we're asking ourselves might be leading to answers to curing cancer, that's not really the focus of our data analytics project. It's curing cancer, all right? Now, why this problem? We're trying to look for, okay, fine. We know that the cause of cancer is whatever it is, degenerated dead cells, cells that are malignant cells. I think that's what they call them. By the way, I have a background in microbiology, but sincerely, I can't even remember the last time I did anything about microbiology. I graduated from OAU with, I'm not going to tell you my grade before you start yabbing me. But anyways, I did microbiology in OAU, and that was like some 10 years ago. I don't even know what exactly I have to do with microbiology. And that's the beauty of data analytics. You could come from any background and go through it. Anyways, once again, just as a slight introduction for those who don't know, my name is Aditayo Kolade. I started Data Analytics Africa like last year. I didn't have so much time to work on it, but with the help of Fumi Owe, yeah, who is like the biggest partner of this project, she's I'm okay, so my name is Tayo Kolade. I'm a data scientist at IHS Stars. Fumi Owe, yeah, is a service manager at Keystone Bank, and she's also a data analytics professional. We are like the pioneer, you know, leaders of this project. We work like day to day on this, trying to spread this knowledge. On the background, I have other partners too, like Dotson, who works in Ikeja Electric. He's a business analyst. I have Ephraim, who is also a lead data analyst at Custodian, and I have Mary, who is an IT project manager in PNG. So I have like a very rich team working with me, and once in a while, it's just good that I appreciate everyone trying to make this a success. Anyways, so as I was saying now, why the problem? You're looking for the cause of the problem. Already we know that cancer is caused by, rogue cells growing in the body, and then um, the last thing is to find out why there's no solution so far. So if you have all of these questions answered, it guides your data analytics process, right? It guides your hypothesis testing. It guides your sorry, excuse me, your model building, your model planning. It guides your data sources. Okay. Now, in most organizations, you have a lot of data stored up somewhere. I made one reference in yesterday's class where I talked about the fact that in most organizations you could have so much data gathered, so much data stored, but sometimes not all of the data you have in within your organization's library or within your organization's knowledge domain is going to be enough in solving your data analytics problem. Sometimes you need to look outside of your organization and bring in data from sources that you do not would probably not even think about. I made the reference yesterday to the bus company that was trying to realize why exactly they were having more complaints on certain days And then from the data they had within the organization, they really could not say anything until they brought in weather data and found out that most of those most of the days they had the biggest complaints were on days when there was heavy rainfall. All right, and because of that, the solution that the data analytics came up with was that, okay, fine, we know the cause of the problem, but you see this problem, there's nothing anybody can do about it. All right, so that is a practical example of why there's asking coming up with, like, okay, so far so good, this problem has existed so far, why has this problem not been solved? Okay, and at the end of the day, this is leading to you coming up with the answers in your data analytics project. So that's the first phase of your data analytics project, right? The discovery phase. Now, okay, so I did this diagram just for you to just see, what is the problem, what is it not. We have this problem because, and we don't have a solution because. This guides your project basically. Yeah, well, yesterday, this is a side note here, is like an answer to the question that I asked you yesterday when I said, give me examples of cases where you could use business analytics to solve like that. So first, to fix the best price for a particular product, to find the best market for a product, to find the best time in the year to procure stock. We made a reference to that yesterday, talking about the best time in the year to procure certain stocks, and we said things like, okay, you know that so far so good from the data you've gathered, you get to sell more jackets in December, right? Because that's winter, and then you don't sell so many jackets in December. You don't sell so many jackets in May because that's like summer, the height of the heat, and not so many people are interested in buying jackets. Okay, so sorry, just forgive me once in a while. I might need to gulp a little bit of water. Okay, so like I was saying, that was a practical example there yesterday. Finding the best market for a product. Take for example, like I always like to use sometimes telecoms references, but because I have a background in telecoms. Okay, no, so now you finding the best market for a product. There was a large data campaign done by NTN when they were trying to release their Pulse data and Pulse plans. Okay, because and then they targeted those plans towards schools. Okay, because they had done the research and found out that, okay, students spend a particular range of amount on calls and maybe more on data, and of course it tailored certain it tailored the pulse plans towards schools, right? And when they launched that, it was mostly popular around university areas. To make best design modifications for a product, of course, like I made reference to something like that yesterday when I said that, okay, you found out that so far so good, most people are buying phones and then phone batteries are not lasting as long as they used to last, and you decide that, okay, as a car manufacturer, apart from just putting a apart from just putting a port where a car charger can be fixed, which is the I've forgotten the name of that port anyways, but to improve your product delivery, you change your car design to include probably a USB port where people can just plug in their USB cables into. With the current designs, you need something to plug into the heater, that heater port, for you to be able to use a charger. But you as a car manufacturer, you've realized that more and more people want to, based on data you've gathered, you've realized more and more people want to be able to charge their phones in their cars. So you slot in a USB port into your car design. All right. So that's like the answers to yesterday's questions. Now, so part of your discovery phase is learning the business domain. Okay. Um, I said something earlier that you need to know whether all the data you require to build your data analytics model, it resides within your organization's business domain or knowledge domain, right? And knowing whether you need to find extra resources outside of your organization to bring in additional knowledge or additional resources to improve your data analytics. Like we said earlier, the case of bringing in data from weather to complement data from complaints to determine why people were complaining on bus trips. Identifying key stakeholders, including anyone who will benefit from the project and who knows about the requirements, right? Discussing with the project sponsors to get an idea of the requirements and the potential working solution. So now, in this case, you as a data analyst working in an organization, your project sponsors are going to be basically your organization's management. For you as a freelance data analyst or data scientist, your project sponsors are basically your clients who gave the job to you to do. All right. So that's the part of learning the business domain. Okay. Now the third thing under your discovery phase is assessing the resources for your project. Okay, the tools and techniques necessary for building the project, the tools and techniques needed to operationalize the project, the tools and techniques required in future for the long-term success of the project. Now, I'm bringing this up for the angle of as a lead data analyst, or for example, or as the data scientist of an organization, your responsibility will actually be to conceptualize the entire data analytics project, right? And that's why I came up with this slide, because it's not just, yes, you will start from the bottom of the ladder in most cases as maybe a junior data analyst, but this is like preparing you for that time. Of course, you will learn through the ranks, but this is more or less like preparing you for that time where you have to like organize the entire project from start to finish. Or let's say if you are a freelance data analyst, it means that okay, fine, you're responsible for this from the very beginning, from day one. Okay, and then it's your responsibility to determine, okay, well, yeah, there's so many data analytics tools. I am going to show you something. There was something that I shared on the Telegram group. For those who are not on the Telegram group, I am going to bring it out. For those who are there, I'm sure you've seen this before. It's basically a picture that shows the tools that are mostly listed for. In fact, the tools and skills that have been mostly listed for data analyst job roles. Okay, you have on a day-to-day basis, you have more and more listings for data analysts on several job boards or job websites, and we saw that there was a particular, you know, I don't know, I can't find this picture, but this is quite unfortunate. I hope I can't find it, but anyways, there was a particular set of tools that was being discussed that people are asking for the most when it comes to data analyst roles. And so, of course, that means that basically you have several tools. Okay, yeah, I found that picture. Okay, I'm going to put this up now. Let me save this and bring it up. Now, okay, I don't know why this is not coming up. Okay, fine. I am going to bring this from here. Don't laugh at my tabs. I want to bring this so that everybody can see. Okay. No, don't switch to any mobile version. So now sorry, excuse me, please. Just a minute. I don't know why I can't get this right on the first try, but let me. Okay, so um, these are like the tools or technologies that are being asked for the most in data analyst job listings. All right, and SQL is like number one tool. Excel, Tableau, Python, R, SAS, PowerPoint, SQL Server, Oracle, Power BI, blah 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 in that order. Okay. Um, Now, you as the data analyst or data, of course, I'm not expecting everybody to be able to use all of these tools. No, far from it. But like we said in our scheme of work, we'll be touching SQL, we'll be touching Excel, we'll be touching Tableau, Python. I won't be touching R. We won't be touching R. SAS, we won't be touching SAS. If you want to learn database tools by yourself, well, I mean, come on, go ahead. Oracle and SQL Server. I think PowerPoint is the most simple tool to use in the world. It's for presenting your findings to management, anyways. Then you have Power BI coming in at a distant, what's that? 1, 2, 3, 4, 5, 6, whatever. But I will suggest to you that while this is very very representative of what people are asking for, it is also important to know that Power BI is a very very important tool, considering the fact that most people or most organizations have Microsoft running on their platform already. Anyways, so continuing this, you as the data analyst or as the lead data analyst or data scientist, it will be your responsibility, of course, to determine what tools out of all of these tools will be necessary for building the project. Of course, you have different resources for doing different things. And one thing I am also going to point out here is this: as a data scientist, you do not have to be a data science generalist. All right, it is okay to be a data science specialist. A data science generalist is trying to put everything into their bucket: data analytics tools, data engineering tools, I mean, all the programming languages in the world, throwing up all the machine learning concepts and technology in the world into their pocket. But of course, you won't be able to do all of that. But having a basic understanding of what tools will be required for what processes exactly will be very, very good. So it involves, so you're assessing the resources for your project, for your data science or for your data analytics project. It involves finding tools that will be necessary for building the project, which could be like your database tools, your analytics, primary data mining tools like K9, RapidMine, and so on. Tools and techniques needed to operationalize the project, which will still involve partly your database tools. Tools that you might require in future for the long-term success of the project. Now, if the skills needed are present in the organization, or if it should be created. Okay. If data available is enough, or should it be brought from somewhere, or should the available data be transformed to carry out the project? So those are like the requirements you will need to involve yourself in when you're assessing the resources for your project. Okay, um, let's continue. Now, data preparation. I mentioned something yesterday about data preparation, and I said something that the lengthiest and the biggest um, problem you would face as a data analyst or a data scientist is data cleaning and preparation. Um, you see, it's an important stage of the project life cycle, and it takes more than 50% of the project's time. All right. Um, the time it takes you to build your data model, the time it takes you to analyze your data and send it out and present your findings is not up to the time you spend cleaning up your data. All right. And part of your data preparation involves preparing an analytical sandbox or workspace. Forgive my background. I usually don't background, but probably in the process of typing and pasting stuff, I could just make a few mistakes. Preparing an analytical sandbox or workspace. That's creating a similar and complete synthetic data space to do the analytics, right? Collecting all kinds and types of data associated with the problem. Okay, it could be, we talked about how your data could be structured or unstructured yesterday. Summary level aggregated data, structured data, text data, call logs, web logs, etc. And which still boils down to what we said earlier, that sometimes the data you need for your data analytics project is not even within your organization's knowledge domain. Okay, we've gone 33 minutes so far, and we have like another 27 minutes to close this class. I will try as much as possible to rush through the rest of what I have here. Now, part of your data preparation involves the ETL process. Um, Task for the class. Jesus, sorry, I'm so sorry. I was supposed to drop this in the channel again. I forgot this. I hope they don't kill me in that channel. Um, Channel people, please forgive me, if you're just joining. I'm so sorry. I was supposed to have dropped this earlier, but as usual, please, for everybody involved, don't just stop at being a member of the channel. Also be a member of the group. It's very easy for us to talk in the group because we have people who interact. We have people to talk to and interact. For the channel, it's not very very interactive. So I mean, sometimes I get to just skip it. But please, let's not. I'm so sorry. I'm dropping this link. Anyways, going back to class. So your data preparation, under your data preparation, you have the extract, transform, and load phase or process. Now, for those of us who were in class yesterday, and okay, even those who were not in class, um, it is essential to note that this is one of the most important processes or steps um, in your data analytics plan. Sorry, just a minute, please. Can someone please pin the link for this class on the data analytics group? DA Africa group. Anybody available? Just so because what we have there still is the link for yesterday's class. If anybody can't do me that favor, I don't know. I find it very difficult pinning my own messages on the group. Okay, so please do me that favor. Thank you. So part of the data analytics and data preparation phase is the ETL, which is the extract, transform, and load. So basically, this process involves you extracting your. Let me put it this way. You know, we said the fact that you might have data from multiple sources, okay? You have data from your database, which is maybe your organization's database. You have data that is coming in from, let's say, sentiment analysis from people's tweets or their Facebook posts and so on. Or you could have data coming in from, I mean, weather reports, the weather channel, or weather reports on them live from news streams and so on. Okay. Your extraction phase involves you bringing all of these data sources together, right? Transforming them by changing the shape of your data. Let me give you something that you might be very, very familiar with, okay? In your transformation, on using Excel, Microsoft Excel as a very classic example, your transformation could involve changing the way your table looks, all right? You could have a table that came in a horizontal dimension, and because you find that you'll be finding it very difficult to apply. I'm going to show you a small example. Okay, let's say this is not a classic ETL process, but I am just going to show you this to demonstrate what ETL looks like. Sometimes you have data that comes in this way, right? Okay, so you have your data coming in a horizontal table format. Of course, these are your headers, okay, basically, and then this is the data contained for each stuff. Now, if we go back to our RDBMS class, we said something that your rows are supposed to contain your records, right? While your columns contain your attributes. In this case, it's been reversed basically. Right now, we're having your rows containing your attributes and your columns containing your records. Of course, it doesn't make any sense to try to attempt to analyze this data like this because even as basic as Excel is as an analytics tool, I mean, come on, you can't throw in a pivot table on this. If we decide to throw in a pivot table, right, what we get is something that's very, very disturbing, right? Rather than having the column headers in this format, we're not having it that way. So your transform processes are something as simple as transposing this data into a method, I mean, to a format that is easier to analyze. Okay, if I throw in a pivot table on this now, well, I know some of us have not used pivot tables before, but I mean, it's easier for me to analyze. I can say order ID and see the number of orders that, I mean, well, in that place. But, anyways, this is just a very, very unnecessary, well, necessary in the sense that at least it gives you an idea of what we're trying to talk about. But yeah, good evening, Sadiq Babatunde. Sorry you're late to this class, but anyway, so as I was saying, your extraction, transformation, and loading process is the process by which you bring your data from all the multiple sources. You transform it into a format that is easy to work with or it's logical to analyze, and then you load it into your data model or into your data engine or into your analytics model. Okay, all along we've been talking about the phases of your data analytics project, starting from the the discovery phase, and that's the phase one. And right now we're on the data preparation phase, which is phase two. Okay, so the ETL process is a very, very important process in the entire data analytics conundrum, and it is good to have. Okay, thank you for pinning on the Telegram group. That's Otokune 4. Sorry, I hope I pronounced your name very well. Hello, Anayo Chris. Welcome to this class. Sorry if you are a little bit late. You can catch up on this after the entire presentation is done. Okay. So like I said earlier, let me just recap on this. You're extracting your data from multiple data sources. You are transforming it into a usable and analyzable format, and then you're loading it into your analytics model. All right, that's the stage, or that's the process involved your for your ETL. Okay, so as I was saying, let me just continue this without. I hope you're not hearing too much background noise. Um, so now, your data preparation also involves developing a familiarity with the data. Now, you cannot analyze data that you do not understand. It will be a very futile attempt at doing anything. You can't analyze data that you don't have a very good understanding of, and that's the part of your developing familiarity with the data involves understanding that data in details. All right. Um, Now you can do a preliminary visualization of your data to sorry, just a minute please guys. Okay, sorry, I'm back. Had to quickly settle a small issue there. So um your you might need to do a preliminary visualization on your data to understand and to see where you have what trends you have, whether they are outliers, okay, and the relationships you have between data variables. Please note that all of the things I'm talking about right now might not be immediately applicable to your first few data analytics projects, but they will be really needed in the future. All right. So just put your mind to it that even though you might not see some of the application of some of these things in the immediate projects we will handle when we start talking, I mean, touching the when we start touching tools like Power BI and Excel or Tableau, you might not really see all of this. Oh, sorry, with Tableau and Power BI, we might actually touch a few of these things, but in the initial stages, you won't see them. But just put it at the back of your mind that in your data analytics project, it's going to be essential to actually just have a random visualization of what your data looks like, see what the trends are like in the values you have, to see if there is any correlation between certain numbers, see if there are outliers. You know what outliers are? Things that do not fall within the line of best fit in your initial visualizations. Now, finding data sets that are needed but not available, and triggering ways to collect new data through open APIs or shares or by purchase. Now, this talks about that point where where we said that sometimes the data you need is not within your organization and you need to bring it out from somewhere else. Sometimes it involves you throwing in an API. Please, is everybody here? Can you hear me? Just in case, I just want to be sure that everybody is still in this class. So, finding data sets that so like we said earlier, bringing in data from other places that you might not really have access to immediately, or that are not within your data domain as an organization. All right. um okay, so that's that for that. Of course, using an API to collect data involves you probably putting an API is an application programming interface which helps you to source data from certain places. For example, let's say Twitter. Okay, thank you everyone. Let's say places like Twitter or Facebook or other data sources, maybe a streaming set of data from a set of smart sensors and so on. Um, so that is that for that. Now, conditioning your data involves cleaning the data. We said it yesterday that sometimes, even when you have put in so many checks and balances in your data collection or data gathering process, there are still situations where the people that are giving you the data that you're working with are still giving you nonsense, right? You're expected to type female in a particular column or in a particular data entry box. You type FEMAIL, or somebody's supposed to type I mean, there are different cases of errors coming in with your data, and in a lot of cases, you have to actually do a lot of data cleaning to the information you're bringing in. Okay, this is very important. This is like a very important aspect of your data preparation. And like we said earlier, that this is the process that takes the most time in your data analysis, your data analytics project, right? So it is good to note that this is something that you cannot afford to joke with. Okay. And it involves analyzing which aspects of a particular database will be useful for later analysis stages. Okay, initially you might be using certain tables from your database, and you might leave certain tables out of your primary analysis. But it's also important to know that while building your data analytics project, you need to know which ones out of the data sets you have I mean, out of the data you have in your database will not be useful in the near future, and to know which ones out of what it is you're leaving out of your project will be useful in the future. This is a very important step. It's a very important step of your data analytics process. Okay, let's move on as fast as possible. Now, model planning. This is phase three. You've discovered your data, right? You've seen all the things that are involved with discovering your data or discovering your project. You've seen, excuse me, just a minute. You've seen all the steps that are involved in discovering your data. You've discovered that data, you've understood that data, or you've understood your problem, basically the problem definition that we talked about. Now, you have asked all the questions: what's the problem, what is not, why do we have this problem, and so on. You've moved on to say, okay, you moved on to phase two, which is basically your data preparation phase, right? So you've discovered that data, you've prepared your data. Now the next thing is to plan your model. Okay, in the scheme of work, in the grand scheme of work, I said that data and building your career as a data analyst or as a data scientist involves certain tools or certain technologies or techniques basically that are not readily available, or I'm sorry, not necessarily readily available, but people don't really pay attention to. Statistics and advanced mathematics would be very essential. Okay, now in building your model, you're going to be dealing with a bit of math and a bit of stats. So you need to be able to understand what kind of analytic models will be required. Are you using association rules? Are you using logistic regression? Are you using linear regression or whatever it is? Now, under your model planning, you need to capture the most essential predictors and variables. Okay, this part of your data analytics process involves a bit of, I think we will take this as another class after we've started our introduction to Excel and our introduction to Power BI. I'm going to take model planning as another class on its own, okay? Because it is very important that um, before you plan your model, you need to basically know, oh, this is actually part of the model planning phase. You need to put at the back of your mind, okay, what and what will be needed for this. Sorry, excuse me. Okay, I wanted to be sure that I had no questions in the chat box. Please, I assume that as I am saying all of these things, you guys understand everything I'm talking about. If at any point in time you do not understand anything, please do not fail to ask me questions. Shout it out in the chat box. Just say like, guy, I don't understand what you are saying. Or I had a hiccup at this point, and I'll be very glad to answer you. All right, please do not forget that the essence of this class is to impact knowledge, is to pass knowledge across. And if I am not passing knowledge, I think you need to ask me questions. Okay, um, so that's that for that. So, as I was saying, your model planning involves you asking yourself what kind of statistical models am I going to, statistical tools or or techniques am I going to throw on this? What kind of machine learning model am I going to use for this particular model? Okay, what model? What machine learning algorithm or what statistical tool will give me the required, the desired answers for the analytics project I'm trying to do. Now, if you see, I put a table right down there for market sector and the kind of analytic techniques or methods that I used. In consumer packaged goods, you could use multiple linear regressions, ARDs, and decision trees. Decision trees are like a decision trees are a machine learning algorithm basically. Retail banking, multiple regression. For retail businesses, you have logistic regression, ARD, and decision trees. In wireless telecoms, you have neural networks, decision trees, hierarchical neural fuzzy systems, rule evolve, and logistic regression. Please, if all of these things are sounding like drama and and very very confusing to you, just put them down somewhere. I will share this document with you at the end of this class, and you can actually use that to just build on your. You can just read through, but just know that there will be separate classes that will talk about all of these things. There will be separate classes that talk about the machine learning algorithms and the statistical techniques that you could throw in on working with your data. All right. So these are the things you need to ask yourself and put into consideration during your model planning phase. Okay. Let me continue on that now. So for example, these are some of the tools you could use for your model planning. Like we said earlier, in the entire data analytics or data science project, you are not necessarily going to be limited to just one tool or software. And depending on your role or your hierarchy in the entire scheme of things, whether you are the lead data scientist or lead data analyst, you might be responsible for determining, okay, what tools or what tools am I going to use for what. R is a predominantly statistical programming tool, okay? And it has 5,000 packages for data analysis and graphical representation, okay? It can interface with databases and ODBC for parallel ingestion of massive data from multiple sources. Same thing goes with Python now. I was supposed to slash this with Python, but because I did not want to start writing again about Python, I just left it like this. Python is also a very, very important tool that, in fact, Python has gradually crept up and overtaken um, R in the scheme of things when it comes to data analytics and data science. But of course, most of the things R can do and even more can be done with Python. There's also a very large support group for Python. All right, SQL analysis services is so SQL is called SSAS, SQL Server Analysis Services. Okay, is basically the engine on which Power BI was built. For those of you who have seen Power BI before, for those of you who have an idea of what Power BI looks like, SSAS was the engine upon which Power BI was built. And right now, the same way Microsoft is pushing in support for Power BI for self-service data analytics, it's the same way they are pushing in massive support for SQL and SSAS. Okay, SSAS is still going to always be in the mix for large organizations who want to still run their analysis from the SQL server directly. Okay, so SSAS can be used for data mining functions and aggregation of basic predictive models. Okay, that's that for SSAS. SAS or Access. SAS is like another tool that we will not be talking about because I don't have the expertise in SAS. If you probably want to learn SAS, that's another one on its own. But um, all of these guys can connect to relational database management systems, and you can use them to, plan your model moving forward. Um, so, okay, so well, I think that was where I stopped on that for model building. Now, I'm sorry, model plan. The next thing is supposed to be model building, but because I could not finish that, I quickly want us to briefly talk about big data. Yesterday, somebody asked a few questions about big data, and I just said I was going to try and answer some of these things in today's class. Okay, as the name implies, big data is very huge data. All right, we're talking about data in the order of petabytes and exabytes. We said one petabyte. Okay, so one petabyte is basically 1,000 terabytes. One exabyte is 1,000 petabytes. So one exabyte means 1 million terabytes, so to speak. so that I don't sound like I just close this abruptly, I stopped at model planning, okay, for our introduction to data analytics today. And because I'm trying to round this class up within the 1 hour time frame, we're going to continue with model building tomorrow, okay? No, sorry, well, not necessarily tomorrow, but hopefully before this week runs out, so that we can do something else for our Saturday and Sunday classes for next week, or is that this week? Okay, so but we will do a recap of what we've learned today. But before we do that, let me just talk about big data. Now, you're getting big data from, you could be getting big data from different sources: online shopping data, log files from telephone companies, satellites, sensors, social networks, demographic data, and so on. Right. So big data basically is very huge data, and it could come in different forms, structured or unstructured. All right. These are the features of big data, and it's called the four V's of big data: the volume, which is the scale of the data; the variety, which is the different forms in which that data comes in; the velocity of the data, analysis of streaming data; and then veracity, the uncertainty of data. I'm going to talk about this one after the other. So, volume basically corresponds to the amount of data gathered by an organization or individuals. Data amount can be of the order of petabytes, exabytes, zettabytes. By 2020, which is the year we're currently in, it is estimated that online transactions shall be 450 billion per day. Now, let's do a simple mathematics, okay? Even if you say, if we were to say that from the basic look of things, I made a reference yesterday when I was talking about 60 million rows of data, right? And we said how large that could be and how it was going to fit in into a record collection system. Now let's do a basic. I'm going to do some basic math here. All right. If I have 450 billion transactions a day, and one of these transactions was just, the transaction record from each transaction was 10 kilobytes, right? It means that I'll be having 450 billion multiplied by 10 kilobytes of data. Okay, that is 4.5 trillion kilobytes of data. All right, if I was going to do that, a gradual division of that, that is going to be 4.5 billion megabytes of data, which is equal to okay, 4.5 million gigabytes of data, which is equal to 4,500 terabytes of data, right? And 4,500 terabytes of data is basically 4.5 petabytes of data. Now, if I'm generating 4.5 petabytes of data in one day, put into consideration how much data I'll generate in 1 month. Okay, and that's where volume comes into play when you're talking about big data. Velocity corresponds to the rate at which that data is generated. Let's take, for example, I talked yesterday about how your mobile phone is a sensor on its own, and how data from your mobile phone is being um, gathered and collected. And imagine how many smartphones you have all over Nigeria, all over the world with the Android operating system. I'm very sure there are over 2.5 billion devices running on Android. And imagine the amount of data coming in from those devices on a per second basis. Okay, the velocity at which that data streams into um, Google servers, right, is contributes to um, what the features of big data could be like. All right, you are not just generating large data, but you are generating that large data over a very very short period of time. Okay, so imagine data flow from sources like, so coming in continuous and more fast than in large quantities like a waterfall case. For example, here is eBay analyzes 5 million transactions per day for frauds from PayPal. That's a lot. Imagine 5 million people trying to commit fraud in a day. That's a lot of data to deal with. Now, variety: big data is generated from different types of sources, internal, external, and are of different formats: structured data, unstructured data, semi-structured like records, text, images, videos, audio files, cookies, JSON, etc. JSON is a data standard. It's a data entry standard. Something that looks more like XML. Or data storage standard looks like XML that can be read by machines. Okay, I don't know if you've heard of JSON this class. If you've not, well, that's what JSON is. You see, so the other task I'm going to drop on here, I'm going to put it on the Telegram group. Um, Sorry, hold on, please. I want you to read and compare between JSON, XML, compare between JSON, XML, and CSV. I have written that in the Telegram group. I'm going to also drop it on this page. Okay, so more info. Okay, excuse me, don't worry about this. Let me just confirm that everything is running fine. Okay, so YouTube is telling me that the stream is not receiving enough video. Anyways, let's continue. Please, can you just signify if what I have on the screen is clear enough on your phones or your devices? Please just do me that favor. If it is, just say yes. That's all. Okay, so as I was saying, then the veracity of your data, sometimes it comes in a very messy nature. It's unclear, inconsistent, in fact mostly incorrect. Imagine you trying to sort through data that's coming in from Twitter, for example. Imagine you trying to deal with conduct sentiment analysis and try to understand what people's sentiments are based off of data coming in from Twitter. Imagine, okay, Aditya Akinsoya, how do we submit these assignments? Well, before I was telling myself that I was going to be expecting people to submit assignments through Google link, Google Drive, I mean Google Form links. But okay, so fine. This is what I'm going to do. In fact, as I'm talking to you now, I'm going to sort out that link for the assignment. Okay. Um, so basically, all I just want you to do is just come up with your. You can just write a paragraph on how or your understanding of the differences between JSON, XML, and CSV. Okay, you can just do it's just like a small term paper. I'm creating that form right now for you to submit. In fact, I don't want you to. Task two is read and compare between. Shit. Task two. Read and compare between JSON, CSV, and XML. It's not options. I'm giving you a paragraph to answer. All right. Task second assignment. Okay. What is the right short essay? Apologies. The findings the above subject. Okay, so basically I'm demanding a paragraph from you. Also, the first thing to have here will probably be just your. I need your emails to. Oh shit. Okay, I need your email addresses. At least your name and your email address, basically. Okay. Short answer. Email. At least that helps me to filter out. That helps me to filter out duplicates. Okay, so I am going to share with you that link. Okay, so the class Telegram group. Please, if you scroll through the chat box, you'll see the link for the class Telegram group. Okay, just scroll up, you'll see I posted it here. But in the meantime, let me first of all drop. This is the link for the assignment. All right. The link to submit your answers on that assignment. Okay. Link to submit assignment. Okay, so I've dropped that on the Telegram group. Okay. Link to submit assignment. Okay. So let's go back to our um okay, just a minute please. I have a few people asking questions on different platforms. Um, we shall continue very, very soon, but just a few minutes so that we can round up this class. I think I've taken much more time than I expected to take. I really don't want us to still stay here beyond 10 o'clock. I will conclude that before 10. Okay, let me just drop this here. Okay. Okay, so let me just go back to our class. So I've dropped you with you guys the link for your assignment submission. Toson Daniel, please can you just confirm if your internet connection is good enough? Sometimes it could be from your internet connection. I think almost every other person here says it's clear enough. All right. So Aditaya Akinsoy, I just dropped you the link for you to submit your assignment. Um, I will take that. Meanwhile, please, you guys should also, I don't mind you screaming at me on the Telegram group so that I get to do this. Submit, share with you guys the streaming, I mean the presentation documents that we used for this class. I will be more than glad to share that with you. Okay, so as I was saying, now the veracity data is usually for big data. One of the challenges with big data, or one of the features of big data, is that it doesn't necessarily come out as something very clear. It doesn't necessarily come out to you as um, very beautiful data. It's a lot of mumbo jumbo, right? And with that, so imagine you trying to analyze 2 petabytes of data and having to correct 2 petabytes of data. I think that gives you an idea of what kind of headaches you will have to go through, right? So that's the last thing I'm going to talk about for the feature of big data. All right. Um, well, so that brings us to the end of this class for now. Like I said, let me just quickly do a quick roundup on what we discussed today. Basically, we continued our data analytics introduction series from yesterday, and we tried to speak about the life cycle of data analytics project, the discovery, data preparation, model planning, model building, and result communication. We were able to successfully talk about discovery, data preparation, and model planning. We've shot this class by 8 minutes already. I think I managed to keep us within the time frame. I think most classes we've hit like 1 hour 22 minutes and so on. But anyways, we've talked about we talked about discovery, we talked about data preparation, we talked about model planning. We will discuss model building and result communication in the next classes. All right, in the next class, and I think all things being equal, in the next class we will finish model building and result communication. Also, in the next class, we are going to be talking about we're going to be talking further into a little bit more about data, big data types and sources of big data. I will be discussing with you one of the things I wrote on the um, on the scheme of work. I talked about under the introduction to data analytics or data analysis essentials. I talked about storage structures and IT infrastructure, which we will also discuss extensively in subsequent classes. Okay, but for now, while we round up on this, it is, excuse me, it's essential to note that um, it's essential to note the 5 basic stages of a data analytics project and how those stages impact you or your face as a data analyst, or your stage or your role in the entire data science conundrum. Your role as either a lead data analyst, a junior data analyst, a senior data scientist, chief data scientist, or anything, a budding person still growing. Of course, probably the data discovery and data preparation phases would probably be your roles if you are in as a new data analyst or a budding data scientist, a junior data scientist. Model planning and model building will probably be the job of, in fact, the model planning and building will probably be the job of a senior data analyst or a lead data scientist. Result communication will probably be done by anybody, but in most cases, at the end of the day, the funny thing about data, or generally not just data analytics, I think in a lot of places, somebody does all the groundwork. You do all the dirty work, and then some boss from nowhere just comes and takes all your all your dirty work and then goes to communicate the results of that work. All right. It is essential to know that at different stages of this data analytics at different stages of this data analytics life cycle, you will be involved in different roles. So this is what we've been able to discuss so far today. I'm going to be sharing this slide with you to give you a better understanding so I can read through and have a better understanding. We will continue with the model building phase of the entire thing, and then we'll talk more in depth about big data. All right. Thank you everybody for joining this class so far. It was nice to have you. Yes, I will share the slides with you. Okay. I will share the slides with you. Okay, the only problem with getting the slides ahead, for you to read ahead, is the fact that so I have to prepare these slides on the fly. Okay. Sometimes it takes, I have a very busy schedule. All right. And sometimes it's not very easy for me combining all of my schedule with creating the slides and so on. But for whatever it's worth, I would do better to share with you all of these slides immediately after the class. All right. Thank you everybody for participating so far. It's been nice having you around. For those who are new here, you can join the Telegram group on you can join the channel DA Africa on Telegram, or you can also, I'll be putting the link for the Telegram group in the description section of this video. Thank you for being a part of this. We will edit and chop up the video and it will be available on the channel for those who missed today's class. Thank you everybody. Thanks for being a part of this. Please and please, like I always ask, if you have any questions, feel free to ask me. I beg you in God's name. I don't want us to just run through this without necessarily having questions. If there's anything that's not clear, if there's anything you're not satisfied with, if there's anything I've said that you have a problem with or you do not understand exactly what I said, please always feel free to ask me questions. In the absence of any questions, I'll be leaving this on for like another 3 minutes so that if you have any questions, you can quickly ask. After 3 minutes, I'll be ending the stream, which will mean that there was no questions from anybody. In the meanwhile, thank you. Yeah, thank you everybody for appreciating my efforts. I also say thank you to you guys. It's a honor and a privilege for me to be able to share the small knowledge I have in my head with you.